Today's AIM Kipsters will be able to solve and compare unit rates from word problems. So when we're looking at this, unit rates are kind of very magical. It gives us an opportunity to take things that are somewhat unalike and compare them, or to take things that are very much alike, but we want to compare them a little bit differently. So the situation that I always think about when I have unit rates is whenever I go to the store, I'm always using unit rates. All right, I go to the store, I find a box of Triscuits. The big box is $4, and it comes for 16 ounces of Triscuits.
What's Triscuits?
It's a cracker. So $4. Oh, sorry. $4 for 16 ounces of Triscuits. There's a smaller box that is $3.50. It is cheaper, but has only 12 ounces. So the question is, which one should we get?
$4.
No matter what it is, I'm going to eat all the Triscuits, all right? So which one is the better deal?
$4.
Raise your hand if you think the first one is the better deal. Raise your hand if you think the second one is the better deal. Okay, so what if I change the price? What if they say, hey, this goes on sale? This is now $3. Which one's the better deal? Raise your hand if the big box is the better deal. Raise your hand if the small box is the better deal. Okay, so here it seems like there is a lot more question. Okay, which one is the better deal? So let's actually go ahead and solve it as if they were on sale. So whenever we're trying to compare things like this, we always want to compare them as a unit rate. A unit rate is something that you are used to solving. I remember when you were talking to me earlier this unit, you said, oh, Ms. Wilcox said time always goes on the bottom. Yep. When you're talking about rates. So what you were doing back then is you were solving for unit rates. Okay? When we're looking at this, we want to compare the cost per ounce. So basically it's kind of like saying per amount of Triscuits, how much am I going to pay? So we know that we want our units, we want to find out how many dollars per ounce. So the units of our answer is this rate, dollars per ounce. This one is super simple. We're given the units exactly as we need them. So if I was trying to set up a rate multiplication, I wouldn't have to do anything but set up. I have $4. And I have, oops, not 30. 16 ounces. My units line up. So actually, all I really have to do here is
Cross multiplication.
divide.
Cross multiplication.
Just like we went to anyway. It's like 1 times 1 times 4. It's
4.
4 over 6. This one's super easy. The units are exactly the way we want them to be. So if I want to know how many dollars per ounce, I'm going to do 4 divided by 16. 4. Pop straight up. 16. Goes in 2 times is 32. Remainder 8. Bring down to 0. Is 80. Goes in 5 times. I get $0.25 per ounce. That means for every ounce of Triscuits that I'm getting, I'm paying 25 cents. So this idea is like comparing fractions. This is the way I always think about this. It's like comparing fractions. Can we compare fractions with different denominators? Not really. There are some things that are going to be obvious, like 1/100th is less than, I don't know, 5/8. Those are going to be obvious, but in general, this is kind of like making sure that they have the same denominator. So we can compare them. So for the small box of Triscuits, it's the same idea. I need it to be in dollars per ounce. Well, I'm given dollars and ounces. So again, this is really simple. $3 divided by the 12 ounces.
I got an actual question.
all we have to do is the division. 3 divided by,
4.
oh my gosh.
It's this.
Top dog goes in the house, Mr. Boots. 3 divided by 12 is also 0.25. So as it turns out, if the small box of Triscuits is on sale, it's actually an equal deal. Doesn't really matter which box you get, you're paying the same amount per ounce of Triscuits. So in this case, you get to decide, how much Triscuits do I really want?
16.
So it's up to you. It's the same deal. Okay?
I got a question.
Yes, Judea.
Why can't you grab multiplication, like put the X there and put the 1 ounce in?
You could, but why?
Because.
You don't need to. Your units tell you how much it is per ounce.
Okay, but.
All right, so looking at this one. The bottom of Mr. Boots' feet have a surface area of 60 square inches. If Mr. Boots weighs 165 pounds, how much pressure, pounds per square inch, will Mr. Boots place on Manuel's back if he stands on Manuel? So, how much pressure, and it tells us the units here. So, this is a problem where it's actually just asking us to find the unit rate. Very basic problem. He will place blank pounds per square inch on Manuel. So you don't have to understand pressure, you just have to understand we need pounds over square inches. So I think about setting this up. I have pounds square inches, that's what I need in my answer. I am given 65 pounds over 60 square inches. So in this case, again, we have the units exactly as we need them. If I want to find out how many pounds per square inch, all I need to do is multiply across and divide. So 165. What S? 165. Goes in 2 times is 120. 45. Count the house, bring it down. Goes in 7 times. Gonna pop that decimal up in between while I'm at it. 30. Another 0. Bring it down. 60 goes into 300. Exactly 5 times. So I get that Mr. Boots will place 2.75 pounds per square inch on Manuel's back. Yes.
Will there be any race like this when we have to add it up?
So let's look at some of the more complicated problems that we could see with unit rates. First one says Caleb runs 6 miles in 30 minutes. His brother runs 12 miles in 1.5 hours. Who was running the fastest speed? Now, so we need a unit rate here. Now, what I see is that I have to find out the speed for each of them. What are we going to use as our units for speed? So this is the important part of this particular problem, is figuring out what units we need for speed. Yes, sir?
Miles per hour.
Miles per hour. So for his answer sentence, Kyrie is going to say Caleb runs blank miles per hour, and his brother, who has no name,
Nehemiah. Oh, nope.
his name is Brother. Brother runs miles per hour. So this case, we need to find out 2 different rates. So I'm going to start with Caleb. And I know Caleb, I need to figure out the miles per hour. Thinking about the information is given to me. I know that he is running a rate of 6 miles per 30 minutes. Are my units okay here? No. So for this one, if I want to get them in miles per hour so I can compare, I'm going to have to change my units a little bit. How can I change my units? Alvaro. Yep. So we're going to throw in that unit conversion, just like we have been for the past couple days. So I can cancel out my minutes with my minutes and get my hours down low. Now I have 60 times 6, which is 360, divided by 30. And I'm going to save you the time. That's 12. Caleb runs 12 miles per hour. So if I want to compare, I also need to know what his brother runs in miles per hour. I know he runs 12 miles in 1.5 hours, but if I want to compare, I need that in a unit rate, miles per hour. So 12 miles per 1.5 hours. Kip yes or Kip no? Are our units okay here?
Yes.
Yeah, here they're good. There's no unit conversion needed, so it's just multiply across
What is that one word?
and then divide. So we have 12 divided by 1.5. Decimal one time, decimal one time. 15 goes into 120 exactly 8 times. So his brother runs 8 miles per hour. Going back to the question, who is running the fastest speed? Caleb. So in order to answer that question, we had to get them both to a unit rate that had the same units. If you want to compare rates, you have to have them have the same units and find the unit rate. Yes, sir.
If you didn't do it mathematically, you could see that Caleb runs more because if you see that he does 6 miles in 30 minutes and his brother does 12 miles in 1.5 hours. So then if we already do it twice, that's already 12 miles in 1 hour. So it's the same, but he's still running more.
I don't feel so smart.
All right, I took Ms. Atkinson, lots of typos here today. It took Ms. Atkinson 6.25 hours, for the 400-mile trip to LA. On average, comma, what speed was she driving? So again, we're talking about a speed, so this one's going to be asking us to solve for a unit rate. We need to know this in what units? Miles per hour. Her speed was blank miles per hour. So I need my answer miles per hour. And the information given to me is actually already a rate, miles per hour, 400 miles per hour per 6.25 hours. So all I have to do in this case is multiply across and divide to find the unit rate. So 400 divided by 6.25, decimal 1 2 times, decimal 1 2 times.
2 times.
This goes into 4,000 6 times.
40,000.
And I get 3,750.
How did you say smart?
No, I've already done this problem once today. All right, subtract 250, and 625 goes into 2,500 4 times exactly. So I know that Ms. Atkinson average speed was 64 miles per hour. Good. She was driving under the speed limit, which was 70 miles per hour. Excellent.
That was a bike.
So this next question is one that they probably could have replaced the previous question with. If they had just said they had gotten rid of this right here, they could have said it took Miss Atkinson 6.25 hours on the way to LA. If Miss Atkinson makes the return trip in 6 hours, how much faster was she driving? So if we want to compare by seeing, all right, if we want to compare by seeing which one is faster, then that means that we have to find the same unit rate for this particular return trip. So for this return trip, I also need to know how many miles per hour. And I'm not given the miles immediately. What's the miles though?
400.
Andrea? 400, because it's the same trip. And the hours this time is 6 hours. Units are all good here. We don't have to convert any units. So we just need to do the 400 divided by the 6. Goes in 6 times is 36. Remainder of 4. Bring down to 0 is 6. It's 36. Remainder 4. So this is going to be 66.6 repeating. So on her return trip, she drove 66.6 miles per hour. Now we just have to think really closely about what this question is asking us. It doesn't ask if she was faster on the way back. It asks how much faster. So what do I need to do? Subtract. So we got 64 up here. So 66 minus 64.6 repeating. 0.6 repeating minus 0 is 0.6 repeating. 6 minus 4 is 2. 6 minus 6 is 0. So we get that she is driving 2.6 repeating miles per hour faster. Lots of problems today. Questions about this? Key points. Kyrie.
When comparing unit rates, no, I don't know.
So he's on the right track. Go ahead.
Make sure you know what they're asking.
Make sure you know what they're asking. That's getting in the right track. Who can help finish up and kind of clarify Kyrie's language here, Andrea? To compare rates, make sure to find a unit rate and this is the important part with the same units. All right, any other key points? Jalen?
When you're, like it's kind of to add on to what you first said.
Okay.
Also to make sure the units are,
All right, any other key points? Okay, let's move on.